Hello everybody, we're going to take a look at Unit 5.2H, which is volume of a cone. Alright, so the last cylinder exercise I used the text problem, the word problem. This time I'm going to use the one with the picture. And we're trying to find the volume of this cone, which has a 15 centimeter radius and a 17 centimeter height. And for this you may need to use, or want to use, you get to use, the GED or WAMAP formula sheets. And if you are planning to take the GED, please use the GED sheet so you get familiar with it. These are your three-dimensional measurements. So here's cone. I'm going to go over here. This is surface area, so that's for painting. How much surface area is there to cover with paint or with paper if you're doing gift wrap. And then over here is volume. And volume of a cone is 1/3 pi r squared times h. So this may sound familiar to some of you. Pi r squared times h is right here. It's the volume of a cylinder. So the volume of a cone is 1/3 of the volume of the equivalent cylinder. And we had an analogous problem up here where we had the area of a triangle is 1/2 of the area of the equivalent square or rectangle. Okay, so you can think of this as 1/2. This is 2 dimensions, and then when we go to 3 dimensions, we're going to take 1/3. So we've got the area of a cylinder, and then we'll take 1/3 of that, and that's how much this cone would be. If you were to imagine a cylinder here, you can almost see 2 more cylinder equivalents coming down, like 2 downward facing cylinders and 1 upward facing cylinder. And it actually works out that one of these cylinders is 1/3 of the total volume. So you get the equivalent of 3 cylinders in each one. Okay, this GED sheet does not have illustrations, but the WAMAP sheet does. So let's take a look at that. And you can make copies of these for yourself. You just click on the link, or you can just work with it from right here. So right circular cone is what we're looking at. Volume is 1/3 pi r squared times h. Okay, so let's take a look at how we're going to work this problem. So we've got 15 centimeter radius on the circle, and then 17 centimeter height. So we're going to first calculate this imaginary cylinder. We're going to calculate the value, the volume of that, and then take 1/3 of that. Okay, so let's substitute. We know pi is pi. So we're going to say 1/3 times pi times r squared times h. And we can just substitute our numbers in here. So 1/3 times pi. We're going to use pi. And if on the GED it says pi is equal to 3.14, use 3.14. Do whatever they tell you to do, or you may get the answer wrong. Pi as a symbol has a lot more precision on most calculators. It will go out to maybe 10 or 20 places, depending on the calculator. And then we're going to square this radius, which is 15, so times 15 squared times the height here is 17 centimeters. It's 17 centimeters tall, and so we'll just put 17 there. And my calculator has refused to help me, so we're going to go ahead and do it this way. Let's see if I get a... All right, so we're going to just put that in. And if you use a fraction in Google, you can put it in parentheses so it knows for sure. that it's a contained unit. So 1/3 times pi, just write pi, times 15, and then that caret key, so that's uppercase 6 with a 2, and times, and let's see, 17. All right, so I don't think we need any parentheses here. What do you think? Should we put some in? Well, let's do this just for safety's sake. We'll calculate all of this by itself, right? So it's going to take 1/3 of this value, right? So we got pi times 15 squared times 17. All right, let's hit enter and see how we did. All right, so the answer here is 4005.53. And before you put in your answer and click check, this, okay, it's in here. They have centimeters cubed here already. Make your answers accurate to at least 2 decimal places. So we're going to put this number in, 4005.53. All right, and that's in. I didn't reset this from the last time. So 4005.53. So if you have questions about this, just go ahead and click Message Instructor and hit send, and I'll try to answer within 24 hours. And go ahead and give this one a try that's written in text, and set your problems up the way we did on the I can't access it now. The way we did on the you don't have to draw the drawing, but if you write out your formula, I would like to see your formula written out, because now we are using calculators legally, but I still have to be reassured that you understand how the process works. So please do that. All right, give this a try, and let me know if you have trouble.